Welcome to our video about the fascinating world of Pokemon and their placement on the Tree of Life. Today, we are taking a closer look at Venausaur and how it fits into the scheme of the Tree of Life. Ready? Let's go! Venausaur, the grass/poison-type Pokemon, can best be compared to the genus Bulbasaurus. Bulbasaurus is a prehistoric synapsid species, described in 2017. Synapsids possessed a single temporal fenestra in the posterior part of the skull. Synapsids originated in the late Carboniferous period and experienced their first flourish in the subsequent periods of the Permian and Triassic. After the mass extinction at the Cretaceous-Paleogene boundary, they experienced a second flourish with the radiation of mammals from the Paleocene onwards, which continues to this day. Modern mammals represent the only lineage from the first synapsid flourish that has survived to the present day. The earliest synapsids, pelycosaurs, looked like typical reptiles and probably lived similarly. Later forms, therapsids, developed a faster metabolism and a constant internal body temperature, endothermy, a secondary palate allowing them to eat and breathe simultaneously, glandular, partially hairy skin, and differentiated teeth with incisors, canines, and molars. Additionally, their posture changed. While many modern reptiles have sprawled legs, the legs of later synapsids, therapsids, supported their bodies more vertically, enabling faster and more enduring locomotion. Dicynodontia were herbivorous synapsids that flourished from the Middle Permian to the early Jurassic. On the Australian continent, they survived until the early Cretaceous. Representatives of Dicynodontia are found on many continents, as during their time, the landmasses still formed the supercontinent Pangaea. Their barrel-shaped bodies suggest a relatively long digestive tract typical of herbivores. Unlike most reptiles, their tails were very short. Their toothless mouths ended in a beak, and on the sides, they had two tusks, hence the name dog teeth, referring to canines, which may have been used for digging in many species. Early dicynodonts, Eodicynodon, Diictodon, were relatively small, around 30 centimeters in length, and likely lived in underground burrows for protection from natural predators like Gorgonopsians. Only a few genera of dicynodonts survived the Great Extinction at the end of the Permian, which wiped out over 90% of all species on Earth, including significant groups like trilobites in the sea and pariasaurs on land. In the Triassic, some groups of dicynodonts underwent another adaptive radiation, developing significantly larger bodies. Among these later dicynodonts, Lystrosaurus, probably living in large herds, was one of the smallest. Much larger were Cannemieria, about 3 meters long, and Placerias, a hippopotamus-like dicynodont, about 3.5 meters long and weighing around a ton. Lystrosaurus was the dominant genus of herbivorous vertebrates in the early Triassic. The late form Lysawiscia from the upper Triassic reached lengths of 4.5 meters, heights of 2.6 meters, and an estimated weight of 9 tons, making it one of the largest land vertebrates of its time, coexisting with dinosaurs. Unlike earlier representatives of this group, they had to watch out for widespread Triassic archosaurs like Proterosuchus or Postosuchus. Occasionally, even relatively small dinosaurs like Coelophysis and cynodonts like Cynognithus could pose a threat, as it is believed they hunted in packs. However, as herd animals, they would not have been easy prey. Shortly after the beginning of the Jurassic, they gradually died out, at a time when herbivorous cynodonts, and especially herbivorous dinosaurs, became more significant. After classifying Venausaur, let's dive into some speculative adaptive evolutionary adaptations. Venausaur has a symbiotic relationship with the plant Rafflesia arnoldii, from which both benefit. While Venausaur grazes comfortably on the sunny fields of Kanto, providing plenty of sunlight, it also defends its plant from other herbivorous Pokemon. The stench of the so-called corpse flower helps deter predators from approaching Venausaur. Venausaur uses its spines similarly to an elephant's trunk, employing them for touching, grasping, and even communication. They can also be used to grab food. That's all for Venausaur. In the next episode, we'll explore Charizard. Do you have any idea which animal it's based on? And how it's related to Venausaur? Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up and subscribe to our channel. See you next time.